Okay, recording now? Okay, perfect. Okay, so this is kind of an open session. It's why does Unicode do that? And so I have a few slides with some questions, but also want to take questions during the presentation. So think of what really annoys you about what we do, and you can ask a question about that. So Ned, I'm sure you have a lot. I'll start it off with XKCD, one of my favorite webcomics. And one I'm always asked if this is me, and it's not, I'm sure. I'm sure this is Joe Becker. We both have beards, but I think this is Joe Becker instead. So the first kind of general topic I wanted to look at is bits, bytes, and code points. There are a lot of questions come up with this. I have, why do Unicode characters use 20 and 1/16 bits? Why do certain programming languages use 16-bit characters? What the heck is it with the bomb character? Why is UTF-8 backwards compatible with ASCII? And why can't the encoding alter character names, code points, normalization forms, etc.? So I can start with any of these, and I'm going to let this be interactive. So raise your hands if you want number 1. Okay, number 2, nobody. Number 3, nobody. Number 4, and number 5. Okay, so let's try number 1. Why do we use 20 and 1/16 bits per character? This seems like a really, really odd number. And what happened was when we first started off, the basic conception of Unicode was we would be a 16-bit character set. And you say, well, how could you fit all the characters we need in 16 bits? It's because our goal was lower. The goal was only modern languages. The goal was to have generative processes for a lot of character sets. And the goal was that we would allocate a bunch of private use space. And if you wanted to do cuneiform, you would do it in private use space. You wouldn't do it elsewhere. So we set out to do that, but it turned out that along the way, there were a lot of compatibility requirements that caused us to expand beyond what we really had intended to do in the first place. And we also had a merger with ISO 10646, and they tossed a whole slew of characters at us that we really didn't want to encode, but we had to in order to get this merger to happen. So we ended up saying, okay, well, we're really going to run out of 16-bit space. How can we extend beyond that? And so we took a look at it. The focus was on trying to fit the majority of characters in 16-bit space, but to have some kind of mechanism where we could go beyond that. And we happen to have a few dozen blocks of 1024 free, unfortunately kind of in the middle instead at the very end. So we decided we would take those and we would divide them into 2 sets, and the first set would be lead characters of a 4-byte form, and the second set would be the trail characters of a 4-byte form, and that was what we did. Luckily, we'd learned from experience with things like the Japanese standard sets where they didn't have a clear division between those, and they had characters that could be both single characters and parts of a double character, which lead you to just horrible results because random access, you end up at a particular point, you look at it, it's an A. Oh no, it's not an A. It's part of a kanji character. And I have to walk back through the characters until I get to a safe spot, and then I know whether it's an A or not. So that was very painful. At least we learned from that. Unfortunately, that was not applied to the flag emoji. So which is, Addison's laughing. That was a mess. Anyway, so we wound up with this situation. We had this extension mechanism. We said, well, we're going for a larger number. And if you look at it and you say, well, I have two chunks of 1,000 code points that I can use in tandem, then what that gets you is another 1,000,000 characters, 20 bits. And we didn't want to have it go to just enough to fit into 20 bits because we weren't that smart. And so better would have been to cut off a little bit of trailing stuff so that it was exactly 20 bits and would fit and wouldn't have to worry about it. So that's the story behind that. Any further questions about that? That's probably even more that you wanted to know, but that's the story behind it. And then when UTF-8 came along, UTF-8 theoretically, with the way it was first proposed, could go way further than that amount, but we ended up taking UTF-8 and saying, well, we're going to define UTF-8 so it also covers exactly the same repertoire as UTF-16. Okay, the second one on it was, I think, why can't the encoding alter character names, code points, normalization forms? When we first began, I mean, the important thing to know is a character standard really has to be stable. You don't want to say, oh, well, I wrote my book here and it's in Arabic, and then I look at it a year later and, oh, all the characters moved around. They're different characters, and I'm getting different glyphs and so on and so forth. So stability is a really important feature of this. And one of the features which was not really required by Unicode, but was required by ISO, was that the character names had to be standard as well. Now, there's an importance to character names in terms of establishing kind of the identity of characters, that a B is different than an A, for example. But we could have allowed us with Unicode originally, we could have allowed for generating a better name than there's a character called an open closed E, which you look at it, you go, and there's a mistake where a name has brackets spelled with just a K instead of a CK in the name. And we could have fixed stuff like that. And instead what we say is the character name is immutable. No matter what mistakes are in there, there's a character called word joiner. Well, that's not a really good name, but we're stuck with it. And instead what we have are aliases. So we have aliases for these things. So if you want to see what the name really ought to be, then you can look at the aliases, and we encourage implementations that show character names to accept or take character names to take the aliases as well, so that you could use them in cases where, for example, in regular expressions, you can have identified characters by name, and they should take the name alias as well. As far as moving characters, that's a big no-no. We did that very early on. Right after we released, we had generated Korean characters by putting together components. So Korean it's a wonderful writing system, and you basically take a small number of components for consonants and vowels and put them into a square, and it's a Korean syllable. So it's a block format like Chinese ideographs, but they're composed of pieces that have meaning, and you can take them apart and look at them and see how to pronounce Korean. So our original mechanism was to use this generative mechanism, which still works, but we got, especially from Microsoft, actually from Bill Gates, I believe, that, well, they couldn't ship in Korea because it didn't have enough characters in it. We did have some composite characters, but they weren't enough. So we ended up saying, well, we can't just leave all of these things in the format they are. We're going to jettison these things, and we're going to put in a big block of Hangul combined characters for Korea. But that meant that we were actually changing the meanings of these green characters because of this block. Well, we did that once, but it was so painful, we decided we would never, ever do it again. And we established a policy that once the character's in, it's in. We could deprecate it, but we would never reuse that character space. And so that's why we have the character names and the code points. Normalization forms, we have a mechanism in Unicode where you can have both a U with an umlaut as a single composite form, or we can have a U with a separate combining umlaut character. And that umlaut character could be combined with an X or Q or a Z or a thorn or any one of these wild number characters. So it's much more general, but we definitely had to have these composite characters because for compatibility with these existing character sets. So what we ended up doing is saying, okay, well, we're going to define the normalization form, and one normalization form kind of splits these things apart. One normalization form puts them together, but we had to make this also absolutely stable. So even though there are some characters where we'd say, well, this really shouldn't have been analyzed this way, it shouldn't break up in this way, it's got to be stable because every computer program can use this and it has to be able to depend upon normalization being stable. So, Rich, actually, is there some water? Maybe I could grab some water in the background while Rich is formulating his question. Thank you.
Well, that raises a question I've always kind of wondered about, which is you have a combining slash, for example, but the O with the slash that's used in Norwegian doesn't decompose to a regular O and the combining slash. I think that's true of like all the combining marks that overlay the base letter, but why was that decision made?
That decision was made by consensus, which I dissented to. So there were a number of people felt like if the character overlaid it, and especially if it had to sort of radically change shape, you get that with some of the things that attach on the bottom of characters, or then the decision was made to go ahead and just leave those as composites. So I can actually write O followed by a slash, and you look at it, and with a good rendering system, it'll look the same. But as far as Unicode is concerned, it just happens to look the same, but it's not the same. So, I mean, one of the takeaways are that we had to do a lot of things for compatibility. And a lot of things, I'll take the bomb, for example. This is this messy character that you can put at the start of a file. And what that tells you is, well, that I'm interpreting the 16-bit chunks that come after it in that file, big endian or little endian. Okay, so either the high byte first or the low byte first. And so this is this awful thing, and people ask, why the heck did you put that in? Why did you extend it so that I could have a UTF-8 bomb at the beginning of file? All of this was compatibility, and in this case, it was another Microsoft thing, but there are lots of things we put in for other companies. I'm not meaning to distinguish them. But they had to have memory map files, and they had to be able to know whether this memory map file, because of the way memory map files work, they had to know what the byte order is in order to determine what the 16, whether this was a high bit or low bit first. So we encoded a character, we picked it, and we picked it so that if you had a byte swapped variant, it was a really unusual combination in ASCII. So the bomb, actually, if you look at it as if the file were ASCII and you look at it, then it's a sort of a weird combination. And that also works for UTF-8, so that you would see this very strange sequence of characters It's very unlikely to be in real files, but it's there. But it is such a source of pain for people because when you concatenate two files, you have to remove it. So what we had to do is give it a semantic so that it was fairly harmless if it showed up there. And that semantic, we ended up, when we kind of wanted to make it really clear for people when this was a zero width joiner or not, we ended up actually creating another character that had this semantic so that we could use it without this overlap in meaning. So that's another case where we had to do it in order to get enough critical mass on board for Unicode to be a success. But because of stability requirements, that's just going to go forever. So this thing's going to be in as long as there's Unicode. Yeah.
So one thing that I've experienced a lot with bombs is that they're generally expected in UTF-8 files.
Yeah.
They're generally unexpected in UTF-8 files, but I've had to kind of hack around a bit and throw them in when those are CSV files intended to open in Excel. Because if you double click those and you don't have a bomb, Excel will corrupt them, treat them as like a local Windows code page and so on. Am I breaking the rules, or is that standard practice to be doing that to maintain compatibility with Microsoft products?
It's there for that it's there for that capability. A lot of more, I'll say, modern products you don't need it. If you open up a random text file, then it'll say, well, you know, I'm gonna scan a few bytes and decide whether or not, well, this is just ASCII or not. But one of the key things in the design of UTF-8 is the single bytes with no high bit set are all the same in ASCII and UTF-8. That's a question that people ask. And that means that you can just treat it as ASCII is just a subset of UTF-8. So, so a lot of modern systems have shifted over to, well, UTF-8 is just the default, and if it's ASCII, well, that's just a subset of it.
And sorry, just a related question. So,
yeah.
In other words, it's not illegal for me to be generating UTF-8 files that start with a bomb.
No,
it's just that it shouldn't normally be needed. And the only reason you'd be inserting them is because you happen to know that your workflow passes through legacy applications that need it.
Yeah. And now, unfortunately, there are a lot of applications that will see it and barf on it too. So it's an uncomfortable position.
So if you're writing UTF-8 parsing code, you should always remember to strip the bombs in case someone has thrown them in.
That's the best option. But as I say, you'll find a lot of systems won't accept the UTF-8 bombs. So
Thank you.
It's an uncomfortable situation.
Thanks for your answers.
Let me see. We have another question, and then I'll switch slides. Okay. So
hi, everybody. For those of you who don't know me, I'm Kathy Wissink. I was at Microsoft about the time that Mark was dealing with all these issues. I have left the company since then. Mark, I think it might be useful for us to riff a little bit on the reality of porting back in the files in terms of the 90s. You know, there is sometimes this perception that people started generating documents and files in like 1998. Whereas for those of us who were doing this work in the 90s, we're doing the lift from legacy code pages, you know, using Windows nomenclature, OEM code pages, ANSI code pages, Windows code, that type of stuff. And I think, you know, there might be a little value in giving a little historical context around that.
Okay, sure. Well, why Unicode started in the first place was it was a god-awful mess. It was, you had, every vendor had its own code page. They were called code pages. So they were assignments of characters to bytes. And every vendor had its own, every country had its own. There were like 3 or 4 different ones for Russia and for Cyrillic, and then multiple other ones. There were modifications of these. I think there were hundreds of these different registered ones and lots of unregistered ones. And a small group of people got together and said, oh God, this is horrible to work with. And Joe Becker had the idea of just saying, well, we're going to take every character in the world and we're going to start with 0 and just put them in one at a time until we're done. And we're still not done, but but that was the basic idea behind Unicode. And there were a huge number of compatibility issues that we had to deal with in order to get people to migrate off of these legacy code pages and into Unicode. So that's part of some of the baggage. What we do is slowly, over time, say, well, you know, this character was really a mistake. We're going to deprecate it. We're not removing it. We just discourage you from using it, or something like that. Yeah.
So,
Yeah. Let me go to some different topic. Is allocating code points.
well, actually, that's,
Is it in that?
yeah, and it's in that space. I'd be interested to hear you say something about the criteria for accepting a character. It seems like some characters or scripts get a lot of scrutiny, require examples. Then we have some characters that are accepted, like a Chinese character that may have only appeared once in a document at one point in history. And then we have emoji, which aren't in use until Unicode makes use of them, with exceptions for some of the mobile vendors and the like. So how are the character acceptance criteria thought about? And I won't mention Klingon.
Okay. Well, when we started, the basic goal was make sure that we can take all of the characters in any of the reasonably high-use code pages and incorporate those into Unicode. Plus, try to cover as many modern languages as we could. So if you look at the allocation of characters in Unicode for Devanagari, which is used for Hindi and other languages, we basically lifted the set off of what was a set defined by the Indian government. And they had a number for a number of different scripts, and we just slapped them into place into roughly the position they were in previously, leaving holes where they had characters that were available elsewhere in Unicode. So a lot of the early work was that was the goal, was just make sure, and we even put in a few things that were in widespread usage that weren't really code pages, but like zap dingbats went in very early. So we had some symbol sets started in. As it went on, we ended up, sort of tightening up the criteria for what would go in, because we were then way out of the range of characters that were in code pages already. And so we started having more and more process around figuring out what are reasonable criteria for adding these characters in, because we didn't want, my daughter drew a scriggle on her kindergarten paper, and well, that's now something that we want to put into Unicode. So we had to have some kind of reasonable boundary, and we have a whole committee set up that's reviewing these things and processing them and looking at comparisons in terms of usage and how well it's defined, whether it's just a nonce character or not. Emoji are related. Basically, we got a proposal in around 2001, I believe. It was from, I think it was from Nokia, for saying, well, they really wanted to have these things into Unicode, these emoji characters from Japan. And we looked at this, and in the Unicode standard at the time said, well, we're not going to have colored, we're not going to have colored things. We're not going to have dance movements. We're not going to have all of these other things. But we looked at this and we said, okay, well, this is just out of scope. Not the kind of thing we're going to do. Later on, about 5 years later on, Google was looking at expanding into Japan, and we had to work with the telecoms. And the telecoms in Japan had all defined their own sets of emoji, which were different. So we had 3 different major sets. And we were looking at it, and you really didn't want to bring these things as images because they had to be part of a mail flow or texting, the equivalent of texting. And so we decided, okay, we'll make a big exception here. we will go ahead for compatibility and say we're going to encode these things and we're going to pick them up and we're going to actually do the work of merging them all into one cohesive set. And you still see remnants of that for a while. The women with bunny ears dancing, not one of my favorite characters, but that was shown as either one woman dancing or as two women dancing, depending upon which vendor you were looking at. And part of it was which vendor in Japan they followed in order to make their decisions. That's also where we got some of the things that were adjusted later on, because vendors that first did their Unicode versions would copy the formats of the emoji in Japan. And the emoji in Japan, whenever they showed human forms, were all light-skinned. And so if you followed that, you only had light skin. When we first did emoji, we said, well, you should show the pictures with an inhuman skin color. So we were thinking of Homer Simpson or Donald Trump, some sort of skin tone that was just not normally found among humans. And so we had, or an avatar character, something like that. Even though that was our recommendation, the vendors really felt that they needed to have compatibility with the Japanese characters. This was intended for Japan, and so they were all light-skinned, which led to us later on adding skin tones in a more general fashion to emoji. Now, what's that? Okay, different question. Okay, one more question on this, and then I'll go to another slide. So, yeah.
So Tex said he wasn't going to bring up Klingon, and I can comment on Klingon.
Okay,
And
great.
it fits in with the prior question. So Peter Constable, I chair the Unicode Technical Committee, and so we're the ones that are ultimately deciding which characters will we encode. And quickly on CJK, yes, there is a slightly different process for CJK, and it's primarily driven by ISO. So they coordinate among East Asian national standards bodies and a few others that have particular interest in CJK Han unification. For other characters besides emojis, symbols, and things that are used in for writing human languages, we have a set of general principles that are the criteria for deciding what to include, and it's relevant for smaller language communities because there are cases, for instance, cases where smaller language communities are inventing their own indigenous scripts. So we have relatively recent inventions. And Klingon sort of fits into a similar category. It was this script that was invented, of course, for this not human language, but this hypothetical entertainment language. And essentially the criterion is, if it's an artifact of human culture, whatever its source, and there is a community of users that wants to interchange digital data in a public environment, and there's evidence that this is being used independent of the original inventor. It's not just the inventor saying, hey, look, I've got something really cool, you should encode it, right? Then technically, it's a potential candidate for encoding. And so Klingon, we have evaluated Klingon and decided there was evidence presented for all those criteria. And so it is technically a candidate for encoding. Now, in that particular case, there are also IP considerations. And so if you want to get Klingon encoded, well, if you can get Paramount Studios to provide a license to Unicode or a statement that they will not hold Unicode or any of its implementing vendors liable for anything if they implement Klingon, then if we see that statement from Paramount, then that would be the last hurdle.
Yeah, thanks. Okay, let's go on to CLDR. So of these questions, or any others that people want to pose, how many people would like to hear question number 1? Okay, question number 2. Question number 3. And question number 4. Okay, it looks like question number 1 is kind of top of the list. So how does CLDR choose its locale codes? Well, Addis and I, years and years ago, were the authors of what's called BCP 47. And this builds upon previous work and basically says that a language tag is a combination of a language code that's defined by ISO and a script code that's defined by ISO and a region code that's defined by ISO, plus variants because you wanted to be able to indicate dialects, plus an extension mechanism. And the extension mechanism allows for people to register as being the owners of this extension mechanism, and that would have tags that went further in. So what you do is you see EN Shavian, SHAV, I think, or SHAW, dash AQ, which is Antarctica. And that would mean English, written in Shavian, and as used in Antarctica. And a variant could be, I don't know, Eastern. Actually, Eastern doesn't make any sense whatsoever. So Central, Central Antarctica. So that could be a variant. And then building upon that, CLDR did a few things. One is that it said, well, the BCP 47 also allows for this thing called an extended language code, an EXT lang. But that is really, the canonical form really puts that in the first place. And the idea was I could say ZH-CMN, and that would say, well, it's CMN, it's really CMN, but we're going to put in the ZH because some software might not be able to understand CM. And so we ended up jettisoning that, and we ended up defining 2 different extensions for that. And these extensions are used for locales. So you can supply extra information beyond that. For example, there's an extension called NU that specifies the number format. So for Arabic, I can say, well, I have AR as in Lebanon, and using the Latin number system. And so we have a set of codes that are basically associated with the script codes that you can use as the values for NU. And that can let me say, I want to have Arabic with Latin numbers. I want to have Arabic with Arabic numbers. I could say I want to have Arabic with Devanagari numbers, and maybe that would work. And maybe, I mean, it'll work if you use CLDR data, but it might not work in some contexts. So that's where we ended up. So we're basically defining an extension of the BCP 47 language codes. All of these are defined by either reference, like pointing to the ISO standards for these particular codes, or within the CLDR data itself. Any questions on that bit? Okay. I think there was a second one was, oh, my user supports that CLDR has a bad value. What do I do? Customarily, what people do is, for example, if you're using CLDR with ICU, is you will take in a version of CLDR, take in ICU, and you'll build your ICU, which has the tools to build from CLDR internally. And so you will patch your version of CLDR if you really want to have a different name for something. So if you can do this by various different mechanisms, but so you'll build your version of CLDR or whatever system that uses it with some patches. We have a mechanism in CLDR called the alt variant, which allows you to do kind of easy patching by saying, well, for this particular item, I really want to use the official version and not the customary version of a particular field. Then your patch file processing can basically be, well, just walk through this and pick the right variant for these particular paths. So that's how I would do it, and that's how many people do it if they want to patch a particular version. We strongly encourage people, if it's not just an idiosyncratic thing, to upstream these changes for a couple reasons. One is because it's way easier if it's already in CLDR and you don't have to patch. I think Rich has said that Apple really enjoys doing the process of applying their patches to the CLDR data. But we don't in Google, putting my Google hat on. And so we try to upstream any changes that we can and try to get agreement from the CLDR Technical Committee to incorporate fixes in. And there are fixes in for CLDR data every release, especially in the lesser used languages. There's not as broad a number of people who are doing the translations, and so we'll find sometimes there are mistakes. There are also tricky bits. The really annoying bits are cases where a country can't agree. So in Norway, we had Norway basically, the kind of native use for time was, I would say, 13.59 for a time. So I would separate the hour and the minute with a dot. But I think through contamination from the tech industry and badly translated software and so on, the colon has come in and become a viable alternative. And so you get, people would say, oh, well, this is wrong. It really needs to be a dot. And we'd say, okay, well, we have a lot of evidence that it should be a dot. We'll change it to a dot. Then all the people who are upset that it was a dot come back in and say, oh, well, it really needs to be a colon. And so we finally put in a mechanism in CLDR where we can flag these things and say, we're not going to let translators make any changes to this unless we get the entire technical committee to agree that this thing needs to be changed, because we just can't deal with the instability. Okay, and then I have a last slide.
Yeah, we have 1 minute left. So
1 minute left.
Yeah.
A minute, a whole minute on ICU. Of these questions, I'll run really quickly. Number 1, number 2, number 3, number 4. Everyone's satisfied with everything, okay?
Everyone wants lunch.
Everyone wants lunch. Number 5. And number 6. Nobody has any questions. Everybody's really happy with ICU. That is wonderful. Thank you, Marcus. Okay. Last question before we go to lunch. And I don't want to be between you and the lunch, so. Oh, yes.
I was just wondering if you could reflect on these last 30 years. I imagine the first 10 years were such so much work went in right at the start that I can imagine feeling like, okay, the project's done. We did all the major scripts. And then, you had another 20 years. But I'm curious how you felt at the time. Did you know you would see something like what Unicode looks like now?
Yeah, I remember I was working at Apple at the time when we were doing a lot of this initial work. And I remember my boss saying, well, are you going to be done next year with Unicode? And it didn't quite turn out that way. So you know, we went through a lot of changes over those years. There were some really unexpected things like emoji. There were a lot of just steady improvement in everything and steady expansion. And the requirements now are much broader. The number of languages we want to serve are much broader. The capabilities are always coming in, and people say, well, why can't I have this kind of thing? And you look at the structure that is in message format, for example, the work that's being done to really extend it and make it easier to internationalize. And just the whole field just keeps on going. I don't see an end to the things that we need to do in order to make software better for people. So.
Okay, well, thank you. Thank you, Mark.
Thank you very much.